What's up everyone, welcome back, Patrick here. Moving on to the next video, we're now going to talk about a special case of factoring, a popular one called the difference of squares. And the way that these kinds of expressions are going to be organized is a little bit unique. Now before getting into the specifics of it, let's do a quick review of if we're just dealing with a simple quadratic. So if we got ax squared plus bx plus c, how have we been factoring something like this? Well, what we've been doing is decomposition. So we've been trying to find two numbers that multiply to AC and then add up to that b value. And then what we do is we decompose that middle term into those two terms, factor by grouping, and then we get our factor. So we've done tons of videos up until this point using that method. Now, an example of a quadratic doesn't necessarily have to be a quadratic. You're going to see over the next couple of videos. Could be a bunch of different expressions that can be factored with a difference of squares. But if we're just looking at quadratics, an example of one would be, for example, something like this: x squared minus 36. Now, when you look at this, notice that at first glance, this seems like it's in a different format than a regular quadratic, but it's actually just the same thing. They're both just quadratics. And before getting into, there's actually a formula for the difference of squares that we're going to be applying and that your teacher will probably teach you and you'll see in the textbook. But before introducing that formula, you can actually take this quadratic and factor it with decomposition. So you actually don't necessarily need anything new. You already have all the tools to factor difference of squares. It's just usually not how it's taught. So I'm going to show you how you could factor this with what you already know with decomposition. Then at the end, I'll show you the formula that is usually introduced. Now over here, notice we have x squared minus 36. Notice there's no middle term over here. There's no bx. But what we can do is we can actually take this and rewrite it as x squared plus 0x minus 36. And so from here, what we can do if we follow that regular decomposition method that we've been doing, notice that the a value is 1. The b value in this case is 0. Okay, so this is like a placeholder that we just put here in the middle. This is just 0 anyway, right? 0 times something ends up just being 0. But I put the 0 there in order to put it in that ax squared plus bx plus c format, just so you could see it still is in that format. It's just one of the terms is 0. So the b value is 0, and then the c value is negative 36. And then what we do, we find two numbers that multiply to 1 times negative 36, which is negative 36, the AC value, and then add up to that B value of 0. And what are those two numbers going to be? Well, it's going to be negative 6 and plus 6. Okay, and when you're factoring a difference of squares, these numbers here in the decomposition process, they're always going to be the same. Even though you're usually not going to be using the decomposition process, again, you're going to be using that formula that I'm going to introduce later on in the video. But just if you do the decomposition process, if that's what you want to stick to with these types of expressions, these numbers here are going to be the same, right? And then that middle term is always going to be 0. So from here, negative 6 times 6 is negative 36. Negative 6 plus 6 is 0. So then notice how we could decompose that middle term into those two terms like that. Then we factor by grouping. From these two, we could take out an x. And then from these two, we could take out a 6. As usual, this bracket should be the same. So we take that out, and we're left with an x plus 6 like that. Right, so this x squared minus 36 factors into these two brackets over here. Now, I want to sort of analyze this relationship between this original expression and then these two factors. And then with that relationship, I'm going to introduce that formula that usually comes about. Notice here how we have the same terms, but all that is different is there's a negative over here and then a positive over here. And that's how a difference of squares is always going to factor. These two are going to be the same. The ends are going to be the same. It's just the sign in between is going to be different. So that's the first thing. The second thing is that this term over here, it's always going to be the square root of this first term. Notice that the square root of x squared is just what? It's just x. So x is going to go here. And then the term that is going to be here, right, that second term in both of the factors is going to be the square root of the last term in the original expression, right? Square root of 36 is 6. So the square root of the first term goes here, the square root of the second term goes here, and then we have a negative or a positive. This could also be positive, this could be negative. The order doesn't matter because you're just multiplying these two factors. And so that's the relationship that's going to hold when you're factoring a difference of squares. So if you have something, this is where I'm going to introduce the formula. So just in general, if you got something like a squared minus b squared, where basically this whole term is able to factor, this is going to equal a minus b, a plus b, like that. So this is the formula that you're going to see. Okay, and this over here, it's actually in this format. So if I rewrite this one more time, so I got x squared minus 36, we could take this and rewrite in this format. Notice that the x squared, it's already in that a squared format. But then the 36, it's not in this b squared format, but we could rewrite this as 6 squared, like that. Okay, and if we rewrite this formula over here just below it, right, this is a minus b, a plus b, like that. Again, this is the square root of that, this is the square root of that, and then there's a negative and then a positive. So notice here, we took this, rewrote it in this format, and now notice that the a value we could tell is x in this case, the b value is 6. So then all we have to do is plug in these into that formula. And so what would we end up with? X minus 6, right? A minus b, a minus b, a plus b, like that, right? Exactly what we got when we did it the decomposition way, right? So this is usually the way that it is taught. You don't usually use decomposition, you don't go through that same process, but I just wanted to show you that you actually can if you want. You have enough tools now to factor whatever expressions. You don't have to worry about these special cases. You can use decomposition if you want, but it's usually not how it is taught. It's taught as like a special case of factoring, and usually this is the formula that is used. And so let's try another one. Let's say we got like 4x squared minus 9, like that. So notice that this is another quadratic here. Again, as I mentioned, it's not just going to be quadratics. You're going to see in the next couple of videos, there's going to be different cases we run into. Sometimes you'll even have multivariable cases. There could be like a y squared over here. But just for this overview video, I'm going to keep it in this format. I'm going to keep it as quadratics, but again, you'll see we're going to run into a bunch of different cases that the difference of squares method can be applied to. So here, factoring this, same steps. What we do, always step 1, which is actually something I didn't mention here, is you check, can you take out a greatest common factor? Notice between the 4 and the 9, you can't do that. So that's always the first thing you check. And then we factor this. So again, you can do it with decomposition if you want, or you can use this formula just to drive the point home further. I'm going to do it with both methods. So notice here the a value is 4, the b value is 0, right? There's like a 0x here. The c value is -9. Find two numbers that multiply to -36. and add up to that b value of 0. Notice in this case, this is just a coincidence here that it's the same two numbers that we got in the previous example. We got a -6 and +6, like that. And so what we could do is that 0x, we can decompose that into these two values here, right? -6x plus 6x gives us 0x, which is just 0, so there's no middle term here. But we found these two numbers to decompose that 0x into. From here, we factor by grouping. We could take out a 2x from these two, which would give us 2x minus 3. And then we could take out a 3 from these two, which would give us 2x minus 3. And then we could take out a 2x minus 3, and we're left with 2x plus 3. Okay, so as expected, notice if we take the square root of this whole thing, we got to take the square root of the 4, which is 2, the square root of x squared, which is x. We get that 2x over here, the square root of 9 is 3, and then we got the negative, we got the positive. So it's following that exact same pattern that I mentioned before. So this here, it factors into 2x minus 3, 2x plus 3. Okay, if we were to use this formula, what you want to do is you want to take this and rewrite it in this kind of format. So you want to make sure that this whole thing is squared, this whole thing is squared. So how can we rewrite 4x squared as something in brackets squared? Because in this case, only the x is being squared, but the 4 is by itself. But what we want is an entire expression that's going to be squared. That's the same as this. It would basically be 2x. Right? Whenever you're multiplying, as a review, whenever you're multiplying two expressions, there's an exponent on the outside. You would take both expressions to that exponent. So applying that here, you'd have 2 to the power 2, x to the power 2, which would give us 4x to the power 2. Okay, so 4x squared we could rewrite as this, and then we got a minus the 9 we can rewrite as 3 squared, like that. And so now, applying it to this formula, notice that the a value is 2x. The b value is the 3. And then we just take these expressions for the a and the b, plug it into those two brackets. So we end up with a minus b, so 2x minus 3, and then a plus b, 2x plus 3. So we end up with that exact same set of factors that we got with decomposition. Right, so multiple ways to do it. A lot of times your teacher may just like tell you to take the square root of this, square root of that, and then just go straight into the answer. Some teachers will want to see this process. They'll want to see you take this, rewrite it in this kind of format, and then use the formula. Some teachers, this is rare, but maybe some teachers will want you to do decomposition like we did with both examples. Right, but in the next couple of videos, I'm going to be more so focusing on using that formula, but whichever way you do it, just make sure you're getting the same values. So over the next couple of videos, we're just going to do a bunch of different cases.